Trigonometry students. I hope you enjoyed the brief guitar introduction. That was a song from a rock group called The Who, called Tommy, done in the 1970s when I was a child. Okay, so we're going to look at a couple of different things in this part of 6.2. What we're going to look at first of all is the length of a subtended arc, and kind of talk about how that goes. We have a simple formula for that, which is S equals r theta, and where r is the radius of the circle, theta is the central angle in radians, and S is the arc. I want to show you where that formula comes from. So we're going to work with a simple proportion, a part to a whole, relating the part of the circle to the whole circle. So we're going to look at the arc length related to the circumference. So the arc length is going to just be what S is. Okay, so I'm going to kind of have you fill out this part. S is the variable we're going to use for the arc length. Okay, a couple of things that are really important on this that we have to know is the length of the subtended arc S is given by the formula S equals r theta, and the measure of the central angle must be in radians. So I want to show you a few little things that you have to know to derive this formula. The circumference of a circle is given by 2 pi r, 2 times pi times the radius. Now we're going to set that equal to, this is kind of the angle in radians, which would be this angle, theta, and then the area of a circle, the entire circle would be 2 pi radians, like that. So what I'm doing is I'm relating the part, which is S, to the whole. The whole is all the way around the circle. That's circumference, that's 2 pi r. So S relates to all the way around the circle. Then we do the part to the whole. We have the angle theta, but we learned that all the way around the circle, remember 2 pi radians is the same as 360 degrees. We've already learned that. So now what I'm going to do is I'm basically just going to solve this equation. I'm going to get rid of the fraction on here. So what I'm going to do is multiply both sides of this equation by 2 pi r. Okay, we can do the same thing to both sides of the equation. That's going to cancel all that stuff out right there. That will give S. Over here, you'll notice that the 2 pi's cross out. So you're left with theta times r. Radians is more like a placeholder than it is a unit. So the radians is just there to show you that that's radian measure. So we end up with S equals theta r, or r theta. That's where that formula comes from. That's a pretty easy thing to grasp when you think about how proportions work. Okay, we're going to go down and work on some examples here. So the key thing is, if you're asked to find the length of a subtended arc, S equals r theta is the formula, and that what's really key is the central angle has to be in radians. If you don't put it in radians, you're going to get some weird answers that will make no sense whatsoever, okay? Let me show you what I mean by that. If you go to this example A down here, we know S is equal to r times theta. Well, the radius is 12. Let's just say that you weren't paying attention and you forgot to change that 45 degrees to radians, because I see students do this, and students should really catch this mistake. I mean, this would be 540. I mean, tell me, there is no way in the world that that thing can be 540 units if the radius is only 12. So it's always important to think about your answers and whether they make sense to you. So here's how you're going to start the problem. You have to start this off. First step is you got to change the 45 degrees to radians. So what we learned in a previous section is you multiply the degrees by pi over 180. Okay, you can simplify that fraction. So both of these numbers divide by 45. So you would have 1/4. So you just get pi over 4. Okay, and now the next thing is we just do S equals r times theta. So we'll do the radius, which is 12, multiplied by theta, which has been converted to pi over 4. You could put the 12 over 1, multiply straight across like you do fractions, and then you could reduce that fraction. So you would actually just get 3 pi on that. So in this problem, the radius is 12, theta is pi over 4 radians, and then we end up with the length of the subtended arc is just 3 pi units. And you can leave that as 3 pi, or you could change that to a decimal if you chose to. So like on my calculator, I could simply just go 3 times pi, and I could get an approximate answer if I wanted to, and I could round that off to S is approximately 9.4. Okay, it's a good idea to just keep pi in that. That way you have an exact answer to that problem. Okay, all right, next problem. What we're going to do here is same thing. I've given you the radius is 5.5 centimeters. This time I've given you that this is in radians. Now, a lot of times students will ask, how do I know it's in radians? Well, you're always going to assume it's in radians unless it has a degree symbol. So if you had 2, you're going to assume that's radians. If it had a degree symbol, then you would know that it's in degrees. Okay, so if it doesn't have a degree symbol, it's radians. All right, so what we do on this is we're going to apply the formula S equals R times theta. So we'll take the radius, which is 15.5 centimeters, and then we're going to multiply that by 3 pi over 5 radians. Now, something I want to mention on this is radians, again, is not really a unit. It's a placeholder. It's just a name that we give for the real number measure of an angle. So now I'm just going to take my calculator. You could take this and multiply it straight across if you wanted to. You could put that over 1, and I'll pull my calculator out, and then you can kind of see how I put this in. So I just do 15.5, and then I'm going to multiply that by 3 pi. Okay, that will get the answer like that. You don't have to write that down, and then divide that by 5. So you can do that all in one step on your calculator. So S is approximately 29.2168, and then you could round that to whatever you wanted to. So I'm just going to say about 29.2 centimeters. And whenever we're doing a subtended arc, the answer should be a unit of distance, like centimeters, inches, that kind of thing. Okay, so that's how you deal with finding the length of a subtended arc. All right, so you can pause the video here if you need to look at this and kind of, think about it a little bit. Otherwise, you can go to the next page, and then what I'm going to have you do is these 2 problems. And on my videos, a lot of times I ask you to try problems. The best thing to do is just pause the video, and when you resume, the answers will magically appear. And then you can check and see if you're doing these right. So I'm going to go ahead and pause the video, and then you can work them out and then check as soon as you're done. Okay, so I'm resuming the video now so you can check your answer. So the answer I got to number 1 was, when I rounded to 1 decimal, was 25.6 meters. And that again gives you the length of this arc right here. That's how long that is. And that's logical. If the radius is 12.2, it looks like that arc's about twice as big, and it is about twice as big. So that's very logical to me visually. So what I did on this is I started by changing the 120 degrees to radians by multiplying by pi over 180 to get 2 pi over 3. Then I do S equals R theta, so I take the radius, and then I multiply that by 2 pi over 3. You do that on your calculator. This is what came out. And you could look at my calculator if you wanted to see what I did. I just did 12.2 times 2 pi. I got the 76. Then I divided by 3. So I just did that in a couple of steps is what I did. Okay, pause the video if you need to write that down or need to look at anything on that. Okay, second problem, you were supposed to find the angle. So I wrote down the formula S equals R theta. The radius was given as 12. The subtended arc S was given as 40.5. So I solved the equation. I have 40.5 is equal to 12 times theta. And I went ahead and put the inches in there because I wanted you to see how the dimensions cancel out from the problem as well. So if I divide both sides by 12 inches, then theta is now by itself. Notice the inches cross out. And then 40.5 divided by 12 is 3.375. And there's no unit on that. I just write radians as a placeholder. But technically an angle in radians is just a numeric value. Okay, so that'll take care of that. That's what you need to know about S equals R theta. I showed you where the formula came from, how to apply that. Remember, the key thing is theta must be in radian measure. Otherwise, your answers won't make any sense whatsoever. All right, so I'm going to go on to the next part, which is area of a sector. Okay, so area of a sector, what this means is this is a piece of a circle. Okay, you can think of it kind of like a slice of pizza, a slice of pie. O is the center of your circle, and then A and B are just 2 points that are on the circle, and then you end up with a central angle that will represent by theta. So we're going to derive the formula that you get for the area of a sector, and we're going to use a part to whole proportion again. There's two things you have to know. You have to know the area of a circle is given by pi r squared, and the circumference of a circle is given by 2 pi r. You generally learn those in geometry. So we're going to do this part to whole. The part is going to be the area of the sector, which would be this part in pink. We're going to compare that to the big, which would be the area of the circle. So the area of a sector, we're going to use capital A for that, and then divided by the area of a circle is given by the formula pi r squared. Okay, then we're going to relate the length of a sector to the circumference of a circle like that. Okay, so when we do a length of an arc length, remember in the previous part of the video we talked about S being the arc length, and then the circumference of a circle would be all the way around, so that's 2 pi r. So again, what I'm doing is I'm relating the area of the piece to the whole area of the circle. I'm then relating the arc length to the distance all the way around the circle. So I'm going to do this. I've got A equals pi r squared. Now remember, S is equal to r theta. So I'm going to replace that and write this part of the proportion r theta over 2 pi r. Now what I'm going to do is I need to solve this equation for A. So I'm going to multiply both sides by pi r squared, and then we'll see kind of what happens. Okay, that will divide out and give you 1a. So now we've got a. You go to this side, it looks like the pi's cross out, and it looks like one of the r's cross out. Okay, so if you have r squared over r, that just gives you r. So we're going to end up having r theta over 2 left over there, and then times r left like that. Okay, so and if it helps you, you could multiply this all together and just say r theta times pi r squared over 2 pi r, and then that cancels, and then one of the r's cancels like that, so you end up with this. So the best way to write this formula is it's r times r is r squared theta over 2, or the way I see it represented most of the time is by this formula. Area equals 1/2 r squared theta. Okay, and again, theta is going to end up having to be in radians in order to get a sensible answer to the problem. So don't use degrees, use radians. So that's where that formula comes from. That's how you get the area of what we call a sector of a circle. Okay, so we're going to go to the next page and we'll do some problems of a few applications on this. So going to the next page, the first thing we have is a picture of a situation. We have a sector shaded in blue here. The central angle's theta, the radius is 12 centimeters. So I'm just going to write down what we have. We have theta equals 100 degrees. Now we need to change that to radians. So when you change to radians, you always multiply by pi over 180 and reduce the fraction. That will give 100 pi over 180. You can reduce, you can divide by 10 and you'll get 10/18. And then you could divide by 2 to get 5/9. So this will end up giving 5 pi over 9. I do want to show you something on the calculator that some of you may not be familiar with. And if you aren't, it's really nice to know this. So if you do 100 divided by 180, if you get into real big numbers, your calculator can reduce this fraction. If you do that, it's going to change it to a decimal. But now if you press your math button and then option 1 convert to fraction and press enter, see it changed that to 5/9 for you. So I'll do that one more time if you're not familiar with that. Just put in the fraction, the calculator will turn that into a decimal, but then go math, option 1, convert to fraction, press enter, and it'll change it back for you. That's really helpful if you get into fractions that are difficult to reduce in one step, if the numbers are real big. Okay, the other thing we have is we have the radius is 12 centimeters. So the second thing I'll do on the problem is we're supposed to find the area of the sector. So we're just going to use the formula 1/2 r squared theta, like that. So we do 1/2, we're going to multiply by the radius, which is 12 centimeters to the second, and then we're going to multiply by the radian measure of the angle, which was 5 pi over 9. Now on this problem, we're going to get both an exact answer and we're also going to get a rounded answer. I do want to keep the units in here because I want to show you how the units work out. So this is 1/2. 12 to the second is 144. Then you would have square centimeters now, because a centimeter times a centimeter is a centimeter squared. Then we'd have times 5 pi over 9, like that. Now what you can do is you could go ahead and multiply this whole thing out. I'm going to go ahead and just move this up here. You could put that over 1. If you want to do it this way, you can. You could also reduce the 144 and 9 if you want to. So I'm just going to pull up my calculator, and we'll have 144 times 5, and that will give me 720 pi when you multiply the numerators out. And then denominator, 2 times 1 times 9 is 18. Okay, then we could take 720 and divide that by 18, and that'll divide out to a whole number. That will give the area is equal to 40 pi square centimeters. And be sure that you put units on this. These problems are not technically correct unless you put the units in there. So we would have that would be the area of the sector. And then if I just go 40 times pi on my calculator, then I could round that off if I chose to, and I could say the area is approximately 125.7 square centimeters. Okay, so that's how you put that problem together, is just use the formula for area of a sector, but make sure that your angle is in radians. Okay, next problem. This one, I don't give you a diagram, I just give you what you need. This one is saying the area of a circle. So this would be the area of the circle is equal to 20.5 square inches. I'm giving you the central angle is 1.2 radians. Now I'm wondering on this if I meant to say the area of a sector of a circle. That's what I think I meant on that. I mean, since we're talking about an area of a sector. So what I'm going to do to solve this problem, we have to find the radius. This is just solving an equation. So let's start by writing down the formula. Area equals 1/2 r squared theta. And then we're going to plug in what we were given. You were given the area of the sector was 20.5 square inches. You were given that that theta was 1.2 radians. And that's important. It's already in radians, so we don't have to worry about converting it. Then we can solve this equation for r. And I'm going to leave the unit in here to show you how this works. So I'll have the equation 20.5 square inches is equal to 1/2 times r squared times 1.2. All right, and then I'm going to kind of work this out like this. There's more than one way you can do this. So I'm going to do this. And you could take 1.2 divided by 2 right now if you wanted to, which is what I would do. You can do it on your calculator if you're not sure what that is. That's just a decimal. So 1.2 divided by 2 is going to give 0.6. So we get 0.6 r to the second now. Okay, now what I'm going to do is I'm going to isolate the r squared. So I'm going to divide both sides by 0.6. And I'll go ahead and just do 20.5 divided by 0.6, and write down whatever decimals I get. And I get a whole bunch of decimals, so I'm just going to write down everything on this. We're going to get an approximate answer anyway. So 34.16, that is repeating sixes. The 7's there because the calculator rounded. Okay, now we have that's equal to r squared. All right, so now you have to do the square root of both sides in order to do this. And when you do a square root of both sides, technically you have a plus minus answer, but a radius, there's no such thing as a negative radius, at least not till the end of trigonometry, when we learn about polar coordinates, I should say. So what I'm going to do is just take my calculator and take the square root of 34, well, it's 34.16, do that square root, and then I'll just round that off, so that's about 5.8. And by the way, I meant to do this, if you carried those inches, if you do the square root of square inches, the square root of anything squared is itself, so it's kind of good to see how those units work out. We expect the units of the radius to be in inches on this problem. Okay, so that's how that problem goes. It's basically getting this set up, and then the details over here of algebra are solving that equation. All right, so what we'll do to kind of finish up this part of the video now is I'll pause the video, and I'll let you all go down now to working out these two problems. Angular velocity on page 4 is in a second part of a video. So go ahead and pause, come back and check your answers when you're done. Okay, so I'm resuming the video. You can now kind of check what your answers were and see if you got these okay. So number 1, I got, you can either have the exact answer, 25 pi over 6 square centimeters, or 13.1 square centimeters as rounding. This one's pretty simple to do. I've already given you the angle in radians, and I've given you radius, so 1/2 r squared theta, just plugging in for the radius, plugging in for the angle, work out the details. That one's just kind of pretty simple, multiplying everything straight across to get that. Okay, number 2's got a little bit more work in it. This one, I gave you the central angle in degrees, so we have to multiply that by pi over 180 to convert that to radians. And one thing that I did on this is, I went through, you can see on my calculator over here, I did 35 divided by 180 to get a decimal. Then I just changed it to a fraction, so I kind of had the calculator help me reduce that then, okay? Then I'm going to plug in the area of the sector. I'm going to plug in the central angle theta. So when I got all that put together, I get this. And then what I need to do, you kind of notice down here, I'm solving for r squared. So I need to multiply. I've got to get rid of this. So I guess what I did is I multiplied 2 times 36 to get 72. So 7 pi over 72 r squared. And then I need to get rid of this fraction, so r squared is by itself. So I multiplied by the reciprocal 72 over 7 pi. All right, that gives r squared by itself. I multiplied straight out on my calculator. It's important that you kind of see how I did this on the calculator too. So 72 times 345 was 24,840 divided by 7 pi. Then I have to do the square root of both sides. Now remember, technically, when you solve the equation, you have a plus minus, but we're not going to have a negative radius in this kind of a problem. We have a positive radius, so we only use the positive. And notice how I put this in. Students are kind of bad about not remembering to put that 7 pi in parentheses. If you do 24,840, if you type it in like this, 24,840 divided by 7 pi, it's not going to do it right, because what it's going to do is it's going to do the division, then it's going to multiply by pi, and that's not right. So you want to have that in parentheses when I do that. Okay, so let me just kind of show you to finish this up. If I put in square root, and then if I do 24,840, I see students do this all the time, divided by 7 pi, you're not going to get the same answer. Okay, that's real important to learn from that experience, because that happens pretty frequently with students. Okay, all right, that'll wrap up the video. I hope you enjoyed that. I hope you enjoyed the the music, and hope you do well with all of your work on this section. All right, good luck, students.